Okay, in this installment, the second installment of Guidesheet 3, we're going to be looking at how we can use mathematical relationships to speed up the process of breaking a vector down into two components. The relationships we want to use are SOH-CATOA. So, sine of an angle is equal to its opposite side of the triangle divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse, and TOA, tangent, is the opposite divided by the adjacent side. Now, the adjacent side is the side that touches the angle. The opposite side is the side that's on across from the angle, and the hypotenuse is the one that is across from the right angle. So this only really works for us broken down this way as long as the angles are right angles. Since we normally break a vector into two perpendicular or 90-degree components, this should work great for us. Okay, so we've got the same three vectors we had in the first section, and we're going to find the components using SOH-CATOA. So the first thing I need to recognize is what is the angle that I'm going to use. I'm going to use this angle right here. Now the whole angle is 300 degrees. That makes this 60 degrees because in a circle we have 360 total degrees. Now that's going to make a horizontal component, and it's going to make a perpendicular component. Now I'm going to draw them like this. Notice that that's head to tail, so red plus blue makes green. This is the 60 degrees. Now it's upside down from the triangle on the top of your paper, but the blue will be the opposite side and the red will be the adjacent side. So when I go to figure out the red component, that's the east-west component, it's adjacent to 60 degrees. So I'm going to use, this is a distance, so distance in x is equal to the hypotenuse, which is 45 kilometers, times the cosine of the angle theta. Again, theta is a Greek letter. We use that, generally speaking, we use that for angles. So in this case, dx is equal to 45 kilometers times 300 degrees. Now, if you have one of these calculators, make sure that when you look at the mode that you're not in radians, you need to be in degrees. So go down to there, click on that, hit enter, and then second quit. Now I'm going to take 45 and I'm going to multiply it by the cosine of 60 degrees. And I get 22.5. So cosine, this is cosine of 60 degrees. Okay, so I get 22 and a half. Right, and that's in kilometers. Then for the blue side, I'm going to be, that's the north-south component. I'm going to want to use, that's dy, that's the distance in the y, or displacement in the y, the hypotenuse times the sine of the angle. Okay, so that's going to be dy equals 45 kilometers, I'm using the same vector, times the sine of 60 degrees. Okay, so 45 times the sine of 60 degrees, and 38.97, I'm going to round it off to 39 kilometers. Now, earlier we said the south component should be larger than the east component, and sure enough, it is. If we wanted to make sure that this had worked correctly, we could add the red side squared plus the blue side squared and see if that gives us the green side squared. So let's do a quick check this time to make sure we're right. 39x squared plus 22.5x squared. Now that's x. That's the green side, the hypotenuse squared. So take second function square root of the answer, and we get 45. Okay, now 45 to 3 significant figures, which is all we really need, and we're correct. All right. So we're going to want to do the same process for the other two. Now, once you get comfortable with this, this is a great way to put trig to work. Easy to use. Just make sure you line up your angles correctly. You know what angle you're talking about. Get your opposites and adjacents figured out. Okay, so the next one's 265. Now that makes this angle right here 85 degrees. Because this hole is 90 and we're just 5 off of 270, so that's 85 degrees. If I go for the east-west component, then it's going to be west. It's not going to be west very much. And then when I go for the north-south component, it's going to be south, down about that much. Now again, those two should be perpendicular to each other. Again, to figure out how much it is, I'm going to want to take distance in the x is going to be, now here's 85 degrees, the x is touching, so that's adjacent, so I'm going to take 10 kilometers this time, 10 kilometers from right there, multiply it by the cosine of 85 degrees. When I do that, I will get cosine of 85. Now, make sure if you're doing it this way with cosine first, you close that parentheses. Otherwise, you're going to run into problems. Times 10 is 0.87, not very much. Okay, so 0.87 kilometers. For the vertical side, we're going to take dy is equal to 10 kilometers, and we're going to multiply it by the sine of 85 degrees, and dy is going to be equal to sine of 85 multiplied by 10, 9.96, very, very close to 10. Kilometers. Okay, so it's almost all straight down, very, very little to the west. Again, we could do a squared plus b squared, a squared plus b squared, check for c squared if we needed to. If you could use this angle, and then your cosines and sines would be opposite, but you still get the same basic answer. Again, before we said that it should be much more south than west. We have just a small component west. Okay, on this next one, we're 200 miles, and our north-south component is a little bit north, and then our east-west component is west. Now it's 150 degrees around from here, because we're going CCW, counterclockwise from 0. That leaves this one to be 30 inside the triangle. So I'm going to use the 30. For the east-west component, I'm going to use the cosine of 30 because this is the angle and the red is touching that angle. So dx is going to be equal to 200 miles this time times the cosine of 30 degrees. And then for the vertical, I'm going to use dy equals 200 miles times the sine of 30 degrees. So we'll do 200 times the sine of 30. Now the sine of 30 is one you'll probably remember, it's 1/2, so that's 100. So this is 100 miles, and then the cosine times 200 and we get 173. Now it's more west than it is north. We said before that should be true. Again, 100 squared plus 173 squared should give us, take the square root of that, we should get back to 200. Okay, so that's how to use SOHCAHTOA. It's a really handy tool. Speeds your life up a lot. You don't have to draw the vectors out every time if you learn how to do it mathematically.